Here you go. Problem number 57. This is not your typical cone problem, but it's fairly standard. We just haven't seen this in a long time, so let's review. They talk about a conical tank leaking water at a rate of 75 cubic inches per minute. Okay, that's going to be important to know. Then they say at the same time water is being pumped into the tank at a constant rate. So we don't know at what rate that's happening. And they say the tank's height is 60 inches, while its diameter is 20 inches. That's shown in the diagram. That's going to be important down the road. The water level is rising. Water level is rising at a rate of 5 inches per minute when the height of water is 10 inches. Find the rate at which water is being pumped into the tank. So, we got some work to do. Diagram is provided for us. Rates. Now let's come up with some things here. Let's say dL dt represents the amount, the rate at which water is leaking. Okay. 75 inches cubed per minute. Well, if we're saying that it's leaking, I guess we're going to say water is leaking at 75 cubic inches per minute. Let's say dP dt represents the rate at which water is being pumped in to the tank. You want to know dP dt when h is 10 inches. But something's kind of strange here because they give us the volume formula. They give us the equation. It says V equals 1/3 pi r squared times h. There's no L's, there's no P's. So what you just got to remember is that dV dt, the change in volume, well, that's going to be the rate at which water is being pumped in minus the rate at which water is being leaked out. So we're going to come back to this at the end of the problem to answer their question. Okay. So let's go to work and differentiate now. The derivative of volume with respect to time is going to be 1/3 pi. Now r squared and h, two different variables. We're going to want to replace one of them. And that's where the information they provided will help us. Let's set h over d, h over diameter. Their height is 60 inches when their diameter is 20 inches. Okay. Now remember, radius is half of the diameter. So h over r, half of 20 is 10 inches. Now, h over r is 60 over 10. Let's get one of these variables by itself. How about let's solve for r and then substitute. So if you cross multiply, we'll get 10h equals 60r. So dividing by 60, 10/60ths, or 1/6 h equals r. Let's substitute here and call this 1/3 pi times r squared, or 1/6 h squared times h. Now we did that to get one variable, and the reason we replaced r is because they gave us information about h being 10, so we're going to want to use h equals 10. We want h still in the equation. Now let's think about this a little bit. Let's see if we can get some more room. Move this stuff over. Okay, now, right here. If we square 1/6, we're going to get 1/36. If we square h, we're going to get h squared times h, all times 1/3 pi. So 1/3 pi times 1/36 h cubed. Okay? That's our volume. All right. Now let's differentiate with respect to t. 1/3 pi times 1/36 is a constant. Now I need to multiply by the derivative of h cubed. It's going to be 3h squared dh dt. All right. You see we've got times 3 and times 1/3. These guys will eliminate each other. Times 3 divided by 3. We can clean this up just a little bit. dv dt is going to equal pi 36ths, pi over 36, times h squared bh dt. Okay. It's our derivative step. Now let's substitute and solve. dv dt. We're going to make a separate substitution. We're just going to write dv dt equals pi 36ths times h squared. They told us they wanted h to be 10 times dh dt. What was the rate at which the water was rising? Should have written this in our rates. They told us right here the water is rising at a rate 5 inches per minute. So we should have said dH dt equals 5 inches per minute. So now we know that we can replace dH dt with 5. Okay, we're getting closer. We're getting closer. Oop. I almost forgot h squared. Oh boy. That doesn't mess you up. H squared, that has to be 10 squared. I initially forgot the exponent. We just put it back on. Our 10 squared is 100. 100 times 5 is 500. So we get dv dt. Oops, go back to the ink. dv dt equals 500 pi over 36 times. Well, that's it. Okay. Now, we're almost there. Remember that we said dv dt is really the rate of change of water being pumped in minus the rate of change of water being leaked out. All right, so let's replace dv dt with dp dt minus dl dt. The rate at which water is being pumped in minus the rate at which water is leaking out. 500 pi over 36. Of course, we can simplify this. We're going to be typing stuff in our calculator in a moment and getting it in decimal anyways. Now, also remember that they told us way back in the problem statement, water is leaking out at a rate of 75 cubic inches per minute. So we can say that dp dt minus 75 equals 500 pi 36. Some old school algebra. We get dp dt equals 500 pi 36 plus 75. Now we'll just go to our calculator and type this in. And you see we're going to get the dp, what just happened, dp dt is about 118.633. See, there will be inches cubed per minute when h equals 10 inches. Okay, well, this is our answer, 118.633 cubic inches per minute. Let's go see which one matches our choice. That's right, they rounded everything. They rounded everything to the nearest integer. So our answer is D, 119 cubic inches per minute. Thanks for hanging in there. This was a tough problem. Hopefully it's a little clearer now than it was before. Good luck on the rest of your work.